Lesson 7, solving systems of inequalities. So we've worked with systems of equations so far, but now we can talk about systems of inequalities. So we've got two inequalities, still the same idea as two unknowns. So our systems of equations that we've worked with, we've been able to solve them graphically or algebraically, meaning by elimination or by substitution. When you're solving inequalities, we only have the option to solve it graphically because there isn't just one solution. There are infinitely many solutions to a system of inequalities. So it says, consider the system shown below. Determine if each of the following points is a solution or not a solution. Show the work that justifies your answer. So we're going to take the point 3, 8, and I'm going to see if it is true in both. For it to be a solution, remember it's that and situation, it's got to be true in both for it to be a solution to the entire system. So 3 plus 8, is that greater than 10? Is 11 greater than 10? And you certainly know that that's true. So if I take that same point and substitute it into the second inequality, I end up with 8 is greater than or equal to 4. And that's absolutely true. So is 3, 8 a solution to that system? Yes. Both are true. Then I want you to do part B and test and see if that is a solution to the system. So you're doing the same exact thing that we did in A. Come to class with that done. Now, if we want to graph this solution, or graph this system to find the solutions, remember, always to be able to graph something, we've got to solve for y. So my slope is -1/1 and my y-intercept is 10 for the first one. The second inequality, y is already isolated, so my slope is 3/1 and my y-intercept is -5. So graphing the first one, I'm up at 10, and then down 1, right 1. And I need to think about my inequality. Okay? It's a greater than, so it's not equal to, so how do we indicate that on the graph? We've got to make that a dotted line. And then where are all of the solutions to this? Where y is greater than. Greater than has got to be above the line. All the values of y are greater than have to be above. And then I graph the second one. My y-intercept is -5. And my slope is up through the right 1. And the inequality symbol is greater than or equal to, so that would indicate a solid line. And where do I need to shade? Y is greater than, again, greater than's got to go above the line. So you could take this idea. Now, in order for it to be a solution to this entire system, it's got to be true for both inequalities. So looking at the shading, where are the solutions for both at the same time? And they're all occurring right in there, so I'm going to put a big S in there for solution set. So could we go back and look to see, is 3, 8 in that solution set? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay. Another way to show that graphically, we showed that that was a solution algebraically. You could test 5, 9 to test to see if your answer was correct for part B. You're going to come to class with exercise 2 done. Let's go over and flip the page. You can do number 3 and come to class with that as well. We're going to make number 4 a warm-up. So if you feel like you'd like to do that one ahead of time, you certainly could do that one. But exercise 4 will be our warm-up. Just as a little hint, okay, when it's y equals a constant, we know that that's going to be a horizontal line. When it's x equals some constant, we know that that's going to be a vertical line. The slope here is going to be 2 over 1, and then the y-intercept, there is no y-intercept there, so okay, the y-intercept is going to be 0. Go ahead and go over to lesson 8. So modeling with systems, and I mentioned this in class, that the Regents isn't going to ask you those fluency kind of questions. They're going to ask you the questions that have some meaning behind them, okay? The word problems. So it says there are many situations that arise in business and engineering that necessitate systems of linear inequalities. So that region, our solution in the xy plane that solves the system, gives us those viable solutions to whatever problem we happen to be talking about. So exercise 1, I want you to do that one on your own and come to class with it. This down here, the graph, is definitely going to be a sketch. Okay, it's not going to be perfect. Okay, so you're just going to get a sketch for that one. You go ahead and flip that over, and let's take a look at exercise 3. So pause the video and take a minute, read through it, get some ideas down, and then restart the video. Okay, so now in exercise 3, I hope you guys have some ideas as to what's going on in the context of the problem. So we have 500 seats in the auditorium. We're selling tickets, and we have $5 for child's tickets and $10 for adult tickets. They must sell at least $200 worth of tickets to cover their expenses. So if X is the children's tickets and Y is the adult tickets, write a system of inequalities that models this situation. So the beginning part gave us that situation. So if you think about X's and Y's, those are our seats, the child seats and the adult seats, and how many seats are in this auditorium. It says that only 500 seats in the auditorium. So if we're going to write an inequality, we've got to say child plus adult has to be less than or equal to 500. We don't have any more seats than that. And then it says to cover their expenses, we must sell at least $2,000 worth of tickets to cover those expenses. So we know that the child's tickets are $5 plus the adult tickets are $10, and we want to make at least, so we could be equal to or greater than $2,000. So that's my system. In part B, they're asking, it says use technology. So you guys are going to use your calculator to sketch this region. So again, it's a sketch. It's not going to be perfect. But in order to put this into your calculator, you know, you have to solve for y. Oops. It's 500. And then the second inequality, we end up with -1/2 x plus 200. So when you enter those two inequalities into your calculator, you're going to have to play around with the window, because look at the size of those y-intercepts. All right, we have a y-intercept of 500 in the first one and a y-intercept of 200 in the second one. So in the graph that they're giving us, okay, is only the first quadrant. So the first quadrant deals with your positives, all your positives. Well, think about the context of the problem. If you're talking about tickets, you can't have negative tickets, and we're talking about money as well. So that's why we're only in the first quadrant. So you could set your window to 0 and, I don't know, play around with it. Try 25 on your x-axis. And then if my y-intercept, if I have a y-intercept of 500, I may set that max up there as 600, so you'll be able to see the graph. But again, you can play around with that and change it so you get a good picture of that graph. So come to class with part B done. It says if the students want to sell exactly 500 tickets and make exactly $2,000. That word exactly is going to be that key there. It says how many of each should they sell? Why is this answer not realistic? So let's look and see what this means. So exactly 500 tickets, and our money equation take it and solve it for X and for Y, and then you come into class and tell me, why is this not realistic? So something's going to be a little weird with your answer. So check that out and see what you come up with. We'll see you in class.